Section 4.3, question number 6, or example number 6. This is the fun stuff. This is what everything has been leading up to. So we're going to start solving equations. Solve the equation cosine 2x equals negative square root of 3 over 2. So keep in mind, instead of this just being theta, it's 2x. So normally we would say theta is equal to the inverse cosine of negative square root of 3 over 2. Right? And of course that would be in quadrant 2 and then also in quadrant 3. So we would want to include that answer as well, which we will do. But because this isn't just a single angle theta, it's actually 2x. It's actually 2x that's the equal this, right? So in other words, 2x is going to be equal to 2 pi thirds, I believe. Because this would be a pi... No, that's a pi sixth reference angle. Why do I feel like I did that wrong somewhere else? Okay, so that would be 5 pi 6. And then, of course, infinitely many answers means we could go all the way around the circle again. So add values of 2 pi, add or subtract values of 2 pi, right? That's our quadrant 2 possibility. We also have quadrant 3 where cosine is negative. Cosine negative ratio in quadrant 2 and quadrant 3. Okay, so our quadrant 3 angle would be 7 pi over 6. And then infinitely many times coterminal angles plus 2 pi k. Well, we want to get rid of this 1/2 because we are just solving for x. So let's go ahead and multiply everything by 1/2. Divide everything by 2. Same idea, right? So divide 2 by 2, and we just are left with x. And 5 pi over 6 divided by 2, or multiplied by 1/2, is 5 pi 12ths. And then 2 pi divided by 2, or multiplied by 1/2, will just be pi times k. Notice how it's just asking us to find the answers from 0 to 2 pi. So I'm answering this question as though I need to find infinitely many answers. But that's important for us to be able to find all of the answers from 0 to 2 pi. So just let me get there and you'll see why I've tacked this on. Okay, next. With 2x equals 7 pi over 6 plus 2 pi k. So we're going to multiply, again, everything by 1/2, divide everything by 2, in other words. So that would be x equals 7 pi over 12 plus pi k. Alright, so we have the framework for our answers. Now what we need to do is plug in values of k to figure out what answers are going to be between 0 and 2 pi. So let's let k equal 0. If we let k equal 0, then we're adding 0, and we will just have 5 pi 12ths. And over here, k equals 0, we will simply have 7 pi 12ths. I mean, k could be a -1, but if we did that, subtract pi from 5 pi 12ths, we're going to be subtracting 12 pi 12ths, and we would get -7 pi 12ths. And that is not between 0 and 2 pi because it's negative. Let's go ahead now and let k equal 1. So now we're going to add pi to 5 pi 12ths. That's like adding 12 pi 12ths to our 5 pi 12ths. So 12 pi 12ths plus 5 pi 12ths is going to be 17 pi 12ths. And then likewise over here, 7 pi 12ths plus pi, which would be 12 pi 12ths. is going to add up to 19 pi 12ths. Alright, what if k equals 2? So that means we would add 24 pi 12ths. That would take us to 29 pi 12ths. But that's bigger than 2 pi, and obviously it's bigger than 2 pi because if k is 2, we're adding 2 pi. And if you add 2 pi to a positive number, you're going to have an answer that's bigger than 2 pi. So we don't need to go any further. This is all of the answers we need that make this equation true from 0 to 2 pi. So something really interesting, if all this had been was theta, then the answers for theta from 0 to 2 pi would have been 5 pi 6 and 7 pi 6, and we would have been done. There would have been two answers, one in each of the quadrants where cosine is negative. But because it was 2x, that made it so that we had 4 answers. If it was 3x, then we might have 6 answers. It takes that number inside of our argument and multiplies it times what we would normally have. Or if it was like cosine of x divided by 2, instead of getting 2 answers, we would only get 1 answer. So just some things to keep in mind to help you know how many answers you're looking for when you're solving problems like this.